Okay, so today we will be doing convolution. That means we will be applying a smoothing filter on our image. This box filter is a smoothing filter or an averaging filter, and this particular is the input image. Now we will be applying this box filter on this input image and making the image blur. So let's see how we will do that. So here you can see the box filter is 3 by 3 filter and our image is a 5 by 5 image. Now we will be applying this box filter on this particular image. Now how convolution works. So as you can see this 3 by 3 filter will be initially placed over this 3 by 3 neighborhood. As the filter is 3 by 3, it will start from this position and it will be initially kept over here. Now what will happen next is this one will be multiplied by this one. We will get 1 by 1 into 1 plus this 8 corresponding to this one will get multiplied by that, plus this 8 will correspond with this one, we will get 8 into 1. Then next row 4 with 1, 4 into 1, then 7 into 1, then 9 into 1, then 5 into 1, 4 into 1, and then finally 6 into 1. So this 3 by 3 after being placed over here will get multiplied with each corresponding value. The pixel values will get multiplied with the corresponding filter values, elements of filter values. And here we will get 1 into 1, 1 plus 8 plus 8 plus 4 plus 7 plus 9 plus 5 plus 4 plus 6. So here we get 6, 4, 10, 15, 15, 24, 24, 31, 35, 35 and 8, 43, 43 and 8, 51, 51 and 1, 52. We get 52, but that's not all. It is an averaging filter, so it has 1 divided by 9 because we are multiplying it and we are averaging it out. So we multiply divide this 52 by 9 because we have to do that. So by dividing 52 by 9 we get 5.77. This is the value we get. Now this 5.77, we cannot have a pixel value in decimal, so we need a complete number. So as it is 5.7 greater than 5.5, we will round it off to 6. Now generally the filter has this point. At this, wherever this point corresponds, that value is being changed of that image. Now when we have placed this filter over here, it is corresponding to this 7. So this value, so the pixel in second row and second column will be replaced by this 6. So here in the output image, instead of 7, we will write 6 over here because that is corresponding to this value. Now when we move forward, so this has been done over here. Now the convolution filter will move forward and it will be placed over this 3 by 3 surrounding, 3 by 3 neighborhood. It will shift it will shift one column. So this will be the next neighborhood on which the filter will get applied. So there what will happen is, so similarly 8 multiplied by 1, we will get 1, 8 multiplied by 1, we will get 1, 0 multiplied by 1, we will get 0, 7 multiplied by 1, 9 multiplied by 1, 5 multiplied by 1, 4 multiplied by 1, 6 multiplied by 1 and 8 multiplied by 1. This is what we will get from this neighborhood. So when we will add this up, 6, 4, 10, 18, 18, 23, 23 and 9, 32, 32 and 7, 39, 39, 40, 47, 47 and 8, 55. We will get 55 for this neighborhood and we will divide it by 9. So we will get around 6.11. Now this 6.11, as it is less than 6.5, we will round it off to 6. If this number we will get is in decimal and it is more than 6.5, then we will do the ceiling operation. That means we will get the next number. And if it is less than 6.5, we will be doing the flooring operation. That means we will get that exact number 6. So now this point is corresponding over here. Second row and third column, so that will be 9 will get replaced by 6. And now so on. What we will do next thing, this box filter we will be placing over here. It will move again one column forward, so it will get placed over here. This 3 by 3 neighborhood 807 957 686, this will get placed over here. Now for that what we will get is 8 into 1 8 plus 0 into 1 0 plus 7 into 1 7 plus 9 into 1 9 plus 5 into 1 5 plus 7 into 1 7 plus 6 into 1 6 plus 8 into 1 8 and plus 6 into 1 6. This is what we will get when we multiply with this. Now again we will do the addition over here. So 6 plus 8 14, 14 plus 6 20, 27, 32, 32 and 9 41, 41 and 7 48, 48 and 8 56. We will get 56 divided by 9. Now we will do again the calculation for 56 divided by 9. We get 6.22. 6.22. Again it is not greater than 6.5, so we'll round it at 6. So now this point is getting corresponded over here 5, so we'll replace it for the 5 with 6. Now as you can see, it cannot move forward. Now this 3 by 3 filter cannot move forward as there is no next column over there. So what will happen, it will get shifted one row down. Now it will get placed over here. So as all columns get occupied from the first iteration, it will get down to the second row. So this is the neighborhood that we will be working on next. Now what will happen? Again it will get applied 4 into 1, 4 into 1 4 plus 7 into 1 7 plus 9 into 1 9 plus 5 into 1 5 plus 4 into 1 4 plus 6 into 1 6 plus 4 into 1 4 plus 2 into 1 2 and plus 0 into 1 0. Now again the addition will happen. 4 plus 2 6 plus 6 12, 12 plus 4 16, 16 plus 5 21, 21 plus 9 30, 37 and 41. 41 will get divided by 9. We get 4.55. Now as it is 0.5, 4.55, we will get the ceiling operation done and we will get the answer 5. Now this pixel or this filter value is getting corresponded in this for this 4, this value. So instead of 4, what we will be writing it as 5. Now it will again shift one column and it will get placed over here. So it came one row down. Now it will move column wise for this row, these 3 rows. So it will work for this one 795 468 201. Now again the addition will be done. 795, so 7 plus 9 plus 5 plus 4 plus 6 plus 8 plus 2 plus 0 plus 1. So 2 plus 1 3, 8 plus 3 11, 11 plus 6 17, 21, 26, 26 and 9, 35, 35 and 7, 42. 42 we get divided by 9. We get 4.66. Now this 4.66 when divided by 5, not divided by 5, 4.66, as it is greater than 4.5, so we will get the next number, that is 5. Now it is corresponding to this 6. This point is corresponding to 6 because this is the neighborhood that we are working on. So instead of 6, what we will write is 5 over here. Now again the filter will get shift to this value. So this neighborhood, 3 by 3 neighborhood. Now working with this, what we will get, 9 plus 5 plus 7 plus 6 plus 8 plus 6 plus 0 plus 1 plus 5. So 5 plus 1 6, 12, 20, 26, 33, 38, 38 and 9, 47. So 47 divided by 9, we will be getting we are getting 5.22. Now as it is less than 0.5, so we will be doing the flooring operation and we will get the number 5. So now it is corresponding, this point is corresponding over here, so instead of 8 we will get 5. Now again there is no column to go forward, so it will come one row down. Now the neighborhood will be this 3 by 3 neighborhood. 5 4 6 4 2 0 0 1 0. So 5 ones are 5 plus 4 plus 6 plus 4 plus 2 plus 0 plus 0 plus 1 plus 0. So what will be getting 1, 3, 7, 13, 17, 17 and 5, 22. 22 divided by 9 we will get 2.44. Now again it is not greater than 5, so 0.5, so we will be getting the answer 2 over here. Now here the 2 value is corresponding to this point, so we will write 2 instead. So the value won't change over there. Now the next point where it will get applied. So the next filter will get applied over here. So it will shift one column ahead. So it will be working on this 468 201 102. Now what will happen here? 4 into 1, 4 plus 6 plus 8 plus 2 plus 0 plus 1 plus 1 plus 0 plus 2. Now 2 plus 1 3 4 6 6 and 14 14 and 20 24. 24 divided by 9 we will get 2.66. Now it is greater than 0.5, so we will get the ceiling function done and we will get the value 3. So this is the point where it is corresponding over here, and as it is the midpoint 468201102. This point is getting corresponded. So instead of 0, what we will be writing it? We will be writing 3 over there. And now finally the filter will get shifted. Again the filter will get shifted to this point, and 686015020. So in this 3 by 3 neighborhood will be taken. Now what we will get is, let me write over here. So 6 plus 8 plus 6 plus 0 plus 1 plus 5 plus 0 plus 2 plus 0. So what we will be getting? 2, 5, 7, 8, 8 and 6, 14, 14 and 8, 14 and 8, 22, 22 and 6, 28. We will be getting 28, and divided by 9 we will be getting 3.11. So instead of 3.11, as it is less than 0.5 decimal, so we will be doing the flooring and we will get 3 value. So instead of this 1, as it is corresponding to this, we will be writing, instead of 1 we will be writing 3 over here. So this is what a smoothing filter does. What it does, see here you will see 7, 9, 5, 4, 6, 8, 2, 0, 1. So the range was right from 0 to 9. So the values were differing that much. But when we applied the smoothing filter, averaging filter, what we got is, we got this result 6, 6, 6, 5, 5, 5, 2, 3, 3. So we are kind of averaging out all the values. So distinct values, whatever distinct values we have, we are averaging out. So in this particular image, we would had edges present over here because there was a difference, huge difference between the values. But when we apply the smoothing filter, what it does is it gets these high frequencies, so high rate of change, to less. It replaces it with a low rate of change. So this is what blurring does. When two pixels, surrounding pixels, get the same values or similar kind of values, they lose the sharpening present in that image. So this is what the box filter does, and this is box filter or smoothing filter does. This is how convolution occurs, and this is what box filter does to the input image. So the input image may have more sharp edges, so that will be removed out. High frequency will be removed out, as the smoothing filter is also known as low pass filter, because it allows the low frequencies and eliminates the high frequencies. It removes the edges and keeps the smooth regions. Now we saw that when we applied the box filter on the input image was 5 by 5, box filter was 3 by 3. So when we applied this 3 by 3 filter on input image, considering this point as the changing value, we got a 3 by 3 output image. Now, generally when we apply any filter on an image, we don't get reduced image. We don't get something like this. So if our input image is 5 by 5, we don't get 3 by 3 image. The resolution or the image size doesn't get changed. So what will happen when this problem occurs? That what solution we need to do is, so when we are applying this point, the center point as the changing value, it cannot get placed over here. It will always get placed over here, because there is a row above, there is a column above, there is a row above and there is a column. So this value cannot start over here. So what the solution for this is? So the solution for this is padding. for this value to be placed over here, what we need is we need one extra row and one extra column, so that this row will get placed on that one extra column and this row will get placed on this one extra row. So for that we need to pad the image. So when our image is 5 by 5 and our output image is 3 by 3, to get this 5 by 5 output image, what we will need to do is we need to make the image 7 by 7. So when we make the image from 5 by 5 to 7 by 7, we will get the original size 5 by 5, and for that we need to do the padding. So there are two ways to pad. Either we can do zero padding. So what we will do, we need one extra row and one extra column for this to get placed over here, and also for this to get placed over here, this needs to correspond over here. So we need one extra column over here and one extra column over here. So what we need to do is we need to increase two rows and two columns. So for that we will be applying the zero padding. So what we will do is add one row of 0 above and add one row of 0 below, and again we need to add one column of 0 and one column of 0. So this way, this is the 7 by 7 image, and when we will apply box filter over that, the one row and one column will get reduced and we will get the original size 5 by 5. Another thing you can do is you can pad with the same numbers that are present on the boundary. So here you can see 18807. Similar numbers should be taken. Again 77650. So 77650. Here also 02010. 04541. The boundary values will get replicated over there. Here the 7 will be taken, here 1 will be taken, here 0 and 0. So whatever the boundary values were there, that gets correspond to add one more column over here, one row over here and one row over here. So when our image gets 7 by 7, so 5 by 5 image, we are adding two rows and two columns, making it 7 by 7. And when we apply convolution or any smoothing filter or sharpening filter on that, the size will get reduced and we'll get 5 by 5. But this is the original size that we provided. So we are not losing the resolution, or we are not losing the size of the image, pixel values of the image. So this is the solution for this thing, for the reducing of the dimensions.